All right. Good, I guess afternoon. I was about to say morning. It's April 13th, I'm going to say. Talking about for Math 2, what the plan for. Ooh, sorry, Kona. Oh, sorry, Cones. Actually, got the dog's tail there a little bit. You'll be all right. Sorry. We'll give some treats. We'll clean that up. Going to talk about what the plan for the quiz on Wednesday is going to look like. So, got a bunch of stuff in here. What I mean by kind of level 2.5 is we're not going super in depth where it's like real, I don't want to phrase this. You're combining a lot of level 2 skills to make a level 3, and there's not really anything in context. But you do kind of have to show a little bit more work, which is why it's a little more than sort of a level 2. The quiz is going to be 6 problems long, and I've got a list of skills right there that 3 times 2, 4 times 2, 5 times 2 or any of those other multiples. Basically, if it makes a nice, pretty Pythagorean triple, all of the integer values, or all of the sides, both legs and hypotenuse, will be an integer value. The missing side, we're going to ask you to certainly do that, so use the Pythagorean theorem for those pieces. We're going to ask if you can identify, is a shape a right triangle? So I know there was a little practice around, is it obtuse or acute? I don't even know that we're going to get that specific, just like, is this a right triangle? Does a squared plus b squared equals c squared work and give you a true statement, or does it give you something where the values are not equal, therefore it is not a right triangle? Um, just like last time, it's going to be accessed through exam login, and you're going to upload the answers to Google Classroom. I'll probably post about an hour time window for you to start it in, or sorry, like once you access it, you'll have an hour, and it'll be live on set like this. These are the skills, which is what we basically covered in 9.1 and 9.2. I'm going to go over sort of the 3 most missed homework problems, and tell you sort of, I guess, things that I was seeing for these. A lot of people were typing decimals. Generally not looking for that too much, and especially if you submit something through Big Ideas and it was like, hey, this is wrong, it might be pretty darn close, but if you're doing some rounding with like a square root 2, things are going to come off there a little funky. So let me show you what I mean, okay? Oops, get rid of that. First one that was sort of the one of the lower ones was this. It was page 529, number 6. I forget which number in the assignment it was, but this is from section 9.2. First thing you have to do is be able to identify what type of triangle is it. Okay, I've got a 45-degree angle here and a 90. The only remaining angle can be 45. So once you know that it's a 45, 45, 90, I want you thinking, do you know all of the equations you need to know? So there's really only one for 45, 45, 90. Your hypotenuse, oops, if I can spell, is going to equal, and this is true for every 45, 90, 45, 45, 90 you get, your leg times the square root of 2. And I'm going to write that one out. Every single time. So you have to look at what we're giving you. Either, and we know in a 45, 45, 90, both legs are going to be congruent. So both of these guys that touch the 90-degree angle are x in this case. Let's substitute what we know. The hypotenuse is this 9 right here, so we're going to rewrite 9 for that, equals. The leg we don't know, and that's the x value. I'm going to keep times square root 2. We're asking you to solve for x. X right now is being multiplied by square root 2, so what am I going to do? Divide both sides by square root 2. On the right side, those are going to cross cancel completely. That's going to give me right now 9 divided by square root 2. And here's where a lot of people started putting in decimals, so it was like spitting out that it was sort of wrong. This is one of the things that we talked about. To clean this up, basically what you're going to do is I'm going to keep the 9 the same. Whatever square root I have in the denominator, I'm going to write up top. So I'm going to put a square root 2, and then my denominator is going to be the same number, just with no root at all. This will come out to like 6.36-ish if you did a decimal sort of thing, and you could take 9 and divide it by square root of 2. This is like 1.41. The square root of 2 divided by 2 is like a 0.707. You can clean all of those things up, but this is going to be the answer that we're looking for. Oh my goodness, sorry, the dog is bumping my hand. Apologies. Well, the big dog, the little dog is still just laying down. That's what I want to see. If you can get to here, I'm probably going to give you most of the points anyhow. Next one. It was page 529. It was basically problem 10. Another, first, can you identify what type of triangle it is? We obviously know it's right. All of these are going to be right triangles. If I have a 30 right here and a 90, my last angle has to be 60. So for this, we've got a 30, 60, 90. There are 2 equations we're going to need. Okay, Kona is the big dog here. Literally right down here, and she's getting angry that I'm not like petting her enough. So if you see me keep getting distracted, it's because this one is angry that I've been on the computer all day so far doing work. Kona, I know, you're just gonna have to wait. Okay? Alright. Alright, back to this. 2 equations we have. If you if you have so let me phrase it this way. Your long leg is equal to the short times, I gotta write this one out as well, the square root of 3. What's your hypotenuse going to equal? Nope, can't spell. There we go. Is equal to your short times 2. You need both of those equations. Now you'll notice to find both your long and hypotenuse, you need to know the short. We're probably only going to give you one and ask you to find the others here. So right now, I've given you the hypotenuse. I know it's the hypotenuse because it is opposite of the 90-degree angle. This is page 529, number 10. I don't know if I stated that or not. I know the hypotenuse. I need to use my hypotenuse equation to go backwards and figure out the short length. What I'm currently going to have is 12 square root 3 equals, and I'm going to put short. The short leg here is always opposite from the 30. So in that case, that's going to be the y. Is this short leg? It's opposite from where that 30 is. So I'm going to write y times 2. You could also write 2y as well. That's totally valid. To solve for this short leg, I'm going to divide both sides by 2. Now, if I clean this up, I currently have y equals, I can do this part right here. I can do the 12 divided by 2 and clean that part up into 6, and then it's still multiplied by square root 3. Leave it like that. Don't figure out what exactly square root of 3 is as a decimal and then multiply that. 6 square root 3 is fine. Now that I know the short leg, I can take the short leg and use this top equation to find out how long the long leg is, in this case, x. So I could write this equation, x equals, so that's my long leg, it's the short, which is y. I already know what that is. I'm going to put 6 square root 3 times square root 3, because it has this second square root 3 right here. The short leg itself is 6 square root 3 long, and then I'm going to multiply by another separate square root 3. What's that going to turn into? X is going to equal still 6 times, now I'm going to put square root 9. When you multiply 2 square roots together, you're allowed to multiply the numbers on the inside. So I'm taking this 3 times the 3 inside both of them to make the 9. In this case, you might realize, okay, hold on, I can clean up square root of 9. I know what that is. It's going to be 3 on its own. So now I have x equals 6 times 3. What's that whole thing turn out to be? 18. So that one actually comes out to like a pretty number. That's totally fine. Believe it or not, this 12 square root 3 is bigger than 18. You can calculate it. Last one. Page 522, number 10. This was from section 9.1. We're basically saying, hey, find the value of x and then find whether it makes a Pythagorean triple. So first step is we're going to find the value of x. You've just got to use your a squared plus b squared is c squared. So let me type that out. Okay, there's the Pythagorean theorem. And when I was doing the sort of lesson for this, I wrote that little question mark here that basically said, is this true? If I get 2 numbers that are exactly equal, I have, that's basically testing if it's a right triangle. Since we're solving for x and we already see right here that this is a right angle, I know the whole shape is going to be a right triangle already. If we didn't have that and we gave you a value, let's say that I put like a 5 here, you tested it with like 5 squared plus 7 squared is 9 squared. If that's true, the triangle is right. But we're not doing that here. You will do that on the quiz, and you have a little bit of practice with that. So we're not actually testing is it equal. We're solving for x. My apologies here. A and B are your legs, the things touching the 90-degree angle. I've got 7 and I've got x. 9 is the hypotenuse. That's your C value because it's opposite of that 90. So this is going to change this equation into x, and then I'm going to have a 7 squared, and that's going to equal 9 squared. So let's clean this up. I'm going to probably write out the rest of these. It's going to give me x squared plus 7 squared is going to be 49. 9 squared is going to be 81. And we're solving to try and get x by itself. I'm going to subtract 49 from both sides. You could do calculator for this. Let's go and pull up a calculator. Again, I have no problem if you use a calculator on a test. 81 minus 49 is going to give me 32. So I'm going to get x squared equals not yet. X squared is equal to 32. Now, my next step to get x by itself is take a square root of both sides. I want to get x here. And we're going to throw away the negative because it doesn't make sense because it's a side length in a triangle. My left side is going to give me x. Here's where we can basically figure out, is it a Pythagorean triple? Can I take a pretty perfect, clean square root of 32? No. If it was square root of 36, we'd have 6 and we'd be good to go. Because I can write square root 32, and I can clean this up, and I'll show you what I mean. I can't clean that up really too much more than that. Like, it's not a nice, clean integer value, like 1 or 7 or 12 or 18. This is not a Pythagorean triple. I'm just going to write PT, because it's going to be a little while to write that whole thing out. If you really want to clean it up, you could write like x equals, and then I'm allowed to split this guy into like, I'm going to do square root 16 and square root 2. The reason is 16 times 2 makes 32, but I can simplify this piece. Get a little bit of this at the beginning of the year. So you could say 4 square root 2. If you give me square root 32 on Wednesday, I can live with it. Okay? It's been a while since we practiced this. If we were physically in class and we were working every day, we'd expect that sort of piece. But we'll be a little lenient here. If you got square root of 32, for right now, the practice quiz is not required, but it is highly recommended. It's live on Big Ideas right now. You'll see I don't know if it's an announcement or an assignment listed, but it is not required if it's an assignment. It is highly encouraged. It is going to only give you sort of one option to basically treat it like a quiz. It will show you scores when you're done, and I believe it gives you sort of the answers and what maybe things you could have done differently for some of those. Take advantage of that. I've got office hours tomorrow at 9 and 2, so if you haven't done your quiz by that point, feel free to sort of drop on in and we can ask questions from any of the book things. Until then, I hope you're staying safe. I hope you're staying healthy and finding something interesting to do. With that, we'll see you all in the future.